Hello everyone. In this lecture we will start a new chapter from class 9th chemistry, that is the periodic table. So in this chapter we will know how the elements were classified on different bases by different scientists. So the first question that comes in our mind is, what is the necessity of classifying elements? So the first topic is need of classification of elements. So as you know that there are so many elements, more than 100 elements that we know about, and if we want to study each element, it will be very difficult task to study every element one by one. So to make our study easy or more convenient, we classified the elements. It means we have kept the similar elements together. So if the properties of some elements are same, we can group those elements together and we can study all these elements together, so that we don't have to study different elements one by one because they all have similar properties. But the question is, how would we know which elements have similar properties? So to identify the elements having similar properties, different people gave different rules. So we will study the different classification of the elements, and the first that we will learn is Doberniers Triads. So what were the Doberniers Triads? Dobernier classified the elements in the group of three. He classified the elements in groups of three, and three, the triads come from three. So that's why these three elements, the group of three elements, were called triads. Now how did he classified these three elements? Means how did he know which three elements should be in a group? So he gave a law. He said that if we arrange these three elements in the increasing order of atomic mass, the average of the atomic mass of first and last element will be equal to the atomic mass of second element. For example, there is lithium, sodium and potassium. Now for Dobernier, it is a triad. It is called a Doberniers triad. Now these three elements have similar properties. And how did he classify these elements? How did he make triads? He took the atomic masses of elements. The atomic mass of lithium is 7, atomic mass of sodium is 23, and atomic mass of potassium is 39. So if we will arrange these elements according to increasing order of atomic mass, the atomic mass of first and last element, that is 7 and 39. So if you will take the average of the atomic mass of first and last element, that is 7 plus 39 by 2. So this is the average, that is equal to 46 by 2, and that is equal to 23. So it should be equal to the atomic mass of the second element. And this is how the Doberniers triads were made. One more example of Doberniers triad is chlorine, bromine and iodine. So the atomic mass of chlorine is 35.5, the atomic mass of bromine is 80, and that of iodine is 127. So if you will take the average of the atomic mass of first and last element, that is 35.5 plus 127 by 2. So that is equal to 162.5 divided by 2, and this is equal to 81.25, which is approximately equal to 80. So this is how he classified the elements. But do we use the Doberniers triads to classify the elements? The answer is no. Why don't we use the Doberniers triad? Because of the limitations of Doberniers triads. Dobernier could not classify all the known elements of that time. He could classify only a few elements. He could make only a few triads. So the other elements were remained unclassified. So we could not use this law to classify the elements because most of the elements are still unclassified. So now we will move to another classification, that is Newland's law of octaves. Now what does Newland's law of octaves say? How did he classify the element? He said that if the elements are arranged in increasing order of their atomic masses, every eighth element will have similar properties to the first element, and this is why it is called the law of octaves. Octaves stand for 8. So the properties of every eighth element will be similar to that of first element. So for an example, if we have so many elements like lithium, then beryllium, boron, then carbon, then nitrogen, oxygen, fluorine, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, potassium and calcium. There are a few examples. So this is the increasing order of atomic masses. You can see the atomic masses of each element in your book. Now if you will see this classification, the property of every eighth element. So if you will count from here 1, 2, 3, 4, 5, 6, 7 and 8. So this is the eighth element from here. If you will count from here, this will be the eighth element from here. So the property of this element and this element will be same. So if you will count from here again 1, 2, 3, 4, 5, 6, 7, 8. So these three elements will have same properties. Similarly, these three elements will have same properties. These elements will have same properties. These elements will have same properties. So this was the Newland's law of octaves. But again, like Doberniers triad, we don't use Newland's law of octaves. And why don't we use the Newland's law of octaves? What were the limitations of Newland's law of octaves? The limitations were that if we move to the elements of higher atomic masses, Newland's law of octaves is not followed. Means if we arrange the elements after calcium, so the properties will not remain same. So since the Newland's law of octaves is not applicable for the elements having higher atomic masses, we cannot use the Newland's law of octaves because only a few elements were classified. So we will move to the next now, that is Mendeleevs Periodic Law and Mendeleevs Periodic Table. So we will know what was the Mendeleevs Periodic Law, because Mendeleevs Periodic Table is based on Mendeleevs Periodic Law. So Mendeleevs Periodic Law says that the physical and chemical properties of elements are periodic functions of their atomic masses. So you have to remember that the physical and chemical properties of elements are the periodic function of their atomic masses. It means if we arrange the elements according to their increasing atomic masses, the properties of elements will repeat after a certain interval. So following this law, Mendeleev arranged the elements in the form of a table, and this table is known as Mendeleev's Periodic Table. So the Mendeleev was the first person who classified all the elements in his periodic table. So therefore Mendeleev's periodic table is very important for us. However, we don't use the Mendeleev's periodic table, but still it was very important for further studies. So let's see what was the importance of Mendeleev's periodic table, why the Mendeleev's periodic table was so important. So the first point that shows the importance of Mendeleev's periodic table was that he classified all the elements, so it was easy for the systematic study of elements. The second point is he corrected the atomic masses of some elements. For example, we have an element here that is boron. So before the Mendeleev corrected the atomic mass of boron, it was known to have atomic mass of approximately 13. But later Mendeleev found that the atomic mass of boron is not 13 but it is 11. So this is how he corrected the atomic masses of some elements, and then he arranged them in increasing order of atomic masses. The next point is, he also predicted some elements which were not discovered at that time. For example, he predicted an element that is called gallium these days, one more that is germanium. So because gallium was below aluminium in his periodic table, gallium was below aluminium, so therefore gallium is also called Ica aluminium. Similarly, germanium comes below silicon, it is called Ica silicon, and it was given the name Ica silicon because it was below the silicon. But since these elements were not discovered, Mendeleev left vacancy for these elements. So this was a huge achievement for Mendeleev. Let's see what were the features of Mendeleev's periodic table. So in Mendeleev's periodic table, there were 7 horizontal rows. These 7 horizontal rows called periods, and there were 9 vertical columns. These 9 vertical columns were called groups. Now these 9 vertical columns or groups were named from 1 to 8 and then 0 group. So this is how Mendeleev classified different elements. Now again the same question, do we use Mendeleev's periodic table? The answer is again no, because Mendeleev's periodic table also have so many limitations. The first limitation is position of hydrogen. As you can see that the hydrogen was placed with the most reactive elements or most reactive metals. However, hydrogen is not a metal. Hydrogen doesn't have the properties of metals. So therefore, it was not justified why the hydrogen was placed with the metals. The second drawback of Mendeleev's periodic table was the position of isotopes. So as you know that hydrogen exists as H11, H12 and H13. Now these 3 atoms, all these 3 atoms are the atoms of hydrogen, but they have different masses. Since in Mendeleev's periodic table the elements were classified according to the masses, and these 3 atoms have different masses, they should have different position in the periodic table, but isotopes did not have different position. They were all placed together in the periodic table. So this was also not justified. The next drawback is anomalous pairs of elements. For example, cobalt and nickel. So in Mendeleev's periodic table, the elements were arranged according to the Mendeleev's periodic law. That means the elements were arranged in increasing order of atomic masses. But the atomic mass of cobalt was found to be more than the atomic mass of nickel. But even after that, cobalt was placed before nickel in the periodic table. So these 2 elements were not following Mendeleev's periodic law. There was one more drawback, that some of the elements which were having different properties were kept in the same group, while some elements which were having same properties were kept in different groups. So because of these drawbacks, we cannot use Mendeleev's periodic table. So hope you have understood all about Doberniers Triads, Newland's law of octaves and Mendeleev's periodic table, and why these tables are not useful for us. So this is all in this lecture. If you have any questions, you can ask your questions in the comment box. Thank you very much.